Everyone, in this video, we will be looking at the 2012 A-Level H2 Math Paper 1 Question 9, which is on vectors. Okay, so in this question, part 1, we are supposed to find a vector equation of the line passing through the points A and B with the following position vectors. Okay, so as usual, we will start off with all the position vectors. So OA is 7, 8, 9. OB is -1, -8, and 1. Okay. So to find the equation of the line, we need a directional vector. So I'm finding the vector AB. So end point minus starting point. This will give me -8, -16, -8. All right. Now, for those of you who does not like to deal with large numbers and negative numbers, what you can do is you can factorize out -8 to make your directional vector looks neater. All right. For those of you who wants to use BA as your directional vector, you can do so. There's no issue. Then after that, for the equation of the line, R equals to 7, 8, 9. This is the position vector of any point on the line. So you can either use point A or point B, up to you, plus lambda directional vector. Okay. So lambda belongs to real number. This is the equation of our line. Part 2, the perpendicular to this line from the point C with position vector 1, 8, 3 meets the line at point N. Okay, so we have another point which is C with position vector 1, 8, 3. And the diagram looks like this. We have a point C over here. This is the line AB. All right, the line AB. The foot of the perpendicular from C to this line AB is point N. Okay, so since N lies on the line AB, ON looks like this. ON equals to 7, 8, 9 plus lambda plus 2 lambda plus lambda. Okay, so I'm using the equation of the line to come out with this position vector of ON in terms of lambda. So if ON looks like this, CN will be endpoint minus starting point minus OC 183. And this will give us 6 plus lambda, 2 lambda, 6 plus lambda. And because we know that CN is perpendicular to the line AB. Therefore, if we use Cn dot the directional vector of the line, we are supposed to get 0. So 6 plus lambda, 2 lambda, 6 plus lambda dot 1, 2, 1 equals to 0. So if you perform the dot product, you will get this. Grouping all the lambdas term together and bringing all the constants to the other side, you have this. All right, so lambda equals to -2. So with this lambda, we can find the position vector of ON. ON equals to 7 plus lambda, 8 plus 2 lambda, 9 plus lambda. So we have 5, 4, 7. Okay. So that is only the first part of the question, finding position vector of N. The next thing we need is the ratio of AN to NB. Okay, so first of all, we need to find out what the position vector of AN is. So AN equals to ON, endpoint minus starting point, minus 8. So ON minus OA. This will give us -2, -4, -2. So the length of AN equals to square root 4 plus 16 plus 4, which is square root 24 units. For Bn, n point minus starting point, so n minus b, we will have, oh sorry, we are finding nb instead of bn, so nb, change this, nb, n point minus starting point, so we take b minus n instead. This will give us, so the length of nb equals to square root 6 square plus 12 square plus 6 square, which is square root 216. Okay, let me move this up a little bit. So if I want to find AN to NB ratio, okay, it will be square root 24 to square root 216. If you factorize out the square number, we will have 2 square root 6 and 6 square root 6. So if you cancel square root 6 on both sides, 2 to 6, 1 is to 3. All right, so this is how we do part 2. For part 3, we are supposed to find a Cartesian equation of the line, which is a reflection of the line AC in the line AB. So in the diagram, AC is here. All right, this is AC. So the reflection of AC about the line AB will be this line over here, passing through C prime, which is a mirror reflection of C in the line AB as well. Okay, so first thing we need to do, okay, before we even talk about the line of the AC prime, we need to find what is OC prime. All right, so using ratio theorem, ON equals to OC prime plus OC over 2, because ON is the midpoint of C and C prime. All right, and we want to find C prime, so we make OC prime the subject minus OC. All right, so this will give us 2,547 minus 183. So OC prime is actually 9011. So with OC prime, we can find the directional vector of the line AC prime. Okay, so as usual, if you want to find C prime A, it's up to you, as long as you have a directional vector of the line. So I would take C prime minus A. 7, 8, 9. This will give me 2, -8, 2. Okay, so like I said, those of you, when you're dealing with directional vector, if you don't like to deal with big numbers, factorize out common factors so that your numbers in the directional vector becomes smaller. Okay, this is optional, it's up to you. Then for the line AC prime, R equals to 9011. So this is a position vector of the line. You can either use C prime, like what I'm doing right now, or if you want to use point A, it is all right, plus mu, because lambda has been used already, so we will be using mu instead, directional vector, where mu belongs to real number. Okay, so this is equation of the line, but the question wants us to give it in Cartesian form. So we need to do one more step. X minus 9 over 1, y minus 0 over -4, z minus 11 over 1. So Let's simplify them. Okay, so there you have it, the Cartesian equation of the line of reflection. So this is how we do question 9 on vectors. I see you guys in the next video for question 10, which is on application of differentiation. All right.